So we'll turn off the contour displacement and let's take a quick look at the stresses. So typically, I guess probably the most common stress plot that we'll use is probably the mid-von Mises stress. And you can see, anytime we turn on one of these color contour plots, we're going to automatically get the scale. The title at the top will tell us what's currently being plotted on the screen and what the overall range is. Now, by default, this range is going to go from the lowest value in the model to the highest value in the model currently being displayed, but that can be controlled also. If we come into the view options dialog here, you can see for the plot legend, we have some controls over the font, the number of blocks that are defined over here. If we want to coarser menu, or we happen to know exactly we want 10 blocks to get a nice even 0, 0.1, 0.2, 0.3, 0.4, and so forth, you can change the default number of blocks. It's normally 16, but you can make it whatever is needed to get a good scale for your range. By default, you see the auto range here from the smallest to the largest plotted, but you can change that to create a specific range. So if you had, say, several load cases and you wanted all of your plots to have the exact same range for a nice even comparison in the report, you can come in and specify what you want your max value to be, as well as to just round this off to a nicer value. Maybe you wanted just 4, 10 to the 8th, and then you get nice even increments along the scale here. Although if you don't manually specify the plot, if we switch to element type and then we replot the stress, oh, it did remember. I thought it was going to move the auto ranging. If we turn that off, it'll switch back. And this is a quick and easy way of finding the highest stress in the model. Now, it might be one tiny small try in an odd place or something. It's not necessarily a large portion of the model. It's one single extreme element somewhere in that model. To help locate it, we can use that auto range feature, and we can say, I know my max is 3.7, so I'm going to make my minimum 3.5 e to the 8th. And now everything below 3.5 is being shown in green, but it's still kind of difficult to find that red element in here. So there's another option in the view toolbar here where you can tell it to hide any of the elements that are outside the current plotted range. So if we just say to hide any elements outside the range, well, anything below that lower threshold, which is the majority of the model, is now just in wireframe. So if we zoom in, we should be able to find that red element in here. And let's get rid of the deformed model, make it a little easier. There's one that's in the range, but it's green. If we use dynamic query and tell it I want my mid stress here, the von Mises stress on that element is, oh, it's beam. Never mind. I need to find a plot or a try. Well, let's try listing elements. So there should be, it's listing everything, even though it's not displaying everything. If there was an area of interest, we could have created a small group or just displaying instead of the entire model here. But you can see all of the information that you can recover in the table view by listing the displayed elements. And when you say list elements and list nodes, it's everything that's currently displayed on the screen that's going to get dumped into this grid view. And you can see we've got all of the different types of stresses along the upper bar here. I don't know if this includes the corner stresses or not in the table here, but we can take a look at that in a minute. When we're evaluating the failure criteria in the next one, you can quickly extract any of the failed material by using this by negative value. Since this isn't actually failing, it's just displaying the stress, we're not going to be able to extract using that, but we might be able to use extract by selected range value. If we set the view part, no, it didn't grab anything. So I'm not sure what that peak stress was in this model. I'll have to look for that later. Let's get back to the normal plot by turning off that exclude, and we will reset the range to show everything here. We can display, the mid X normal, mid Y, or mid shear. Now these are for the local plate directions. So when we're displaying mid X here, that's the local X on each one of these elements. And if we come in and use dynamic query, looking at the direction of the arrow, that defines node 1 to node 2 on this element. Node 1 to node 2, or just looking at the arrow on the element, that is the X direction for this particular element. That's the local X. And there's no guarantee that they're all going to be aligned. So you can see these ones on the edge, the X direction is longitudinal. These inboard ones, the X direction is transverse. So I guess it's not so much a problem with the von Mises stress. But if you want a nice uniform plot, we can have Maestro automatically align all of the element directions, and we can plot directional stress. So if we turn on directional stress here, we don't see a change initially because everything is still using its own local direction. But we can tell it to define the direction so we can see what's going on, tell it to show the direction. So if we look at each one of these, and I'll switch back to the element view, you can see all of these elements have the X direction, the local X in the transverse direction. These ones we were looking at on the edge are longitudinal, and we can align all of those very easily by just saying define direction. And we can do the full model or just a current view part. So if we just set, the bulkheads, the decks, or I think if we just created a group of what we wanted to modify, we could come in and change the X directions on these elements. And you got a number of options for what to use as your reference for how they're going to be specified. And there's also a user-defined cutting plane option here. By default, we'll try the global X with the default XZ, XY cutting plane and say OK. And the way Maestro aligns these, all of our deck elements are now aligned in the longitudinal direction, and all of our bulkhead elements are aligned transversely. View our results for the mid-X. Now you can see we have a nice uniform contour along that outer edge there, and we can turn off the show direction. Just view the overall contours. Now, currently, each element only has a single shade for coloring. We can also turn on contours similar to what we did with the displacements, and it'll switch that to a much softer contour plot. So we can see some of the transitions a little more clearly, and this will also help highlight any hotspots in some areas. Like if we go back to the additional mass plot, this is still on a fairly high scale, and I think that's because we have it specified to use that scale. I'm going to turn off the apply defined range, and you can see we have a few elements in here with some fairly bright red. If we go back to the standard coloring, they don't stand out quite as much when you have to use, the average value for the entire element. When we turn on the contours, it can accentuate some of those hotspots. There's also an option in here to view the mid-principal stresses. You can find the max or the min of the stress in the principal directions, which I guess would be more used for fatigue evaluations. And there is also an option here to, instead of plotting the mid values on all of your elements here, you could also plot either the top or bottom values, and they have similar options here. The plate X, plate Y, the shear, or von Mises, you can plot at the top or the bottom of the plate. And for the bottom, there is also an option for the stiffener flange stress, although I'd have to look up what exactly that is. Typically, we just plot the von Mises. What exactly would get displayed there, I'd need to look up in the help file. And there's also an option to plot the beam stresses. Now, if we plot say the beam flange mid stress, so you can see all of our beams now are colored to those values. Again, we're still plotting directional stresses here. The directional stress probably doesn't really apply to the beams, so it shouldn't have much effect there. If we switch back to, let's say we'll plot the von Mises here, and we'll look at what we can use the dynamic query to recover from the model here. We can query the mid, top, and bottom stresses as well as corner stresses here. So we come into the model, and let's say we want to see exactly what the values are in this area. It's quite a bit of information displayed here. So you can see basic information at the top, the thickness of that plate, the FE tag, which is just automatically assigned, but then we see the XY shear and von Mises stresses for the mid plate, then similar values for the top plate or the top of that plate, and then the bottom of that plate. And then following it, we see all of the corner stresses. And for each corner, we get XY shear and von Mises in a group there. And we get those also at mid, top, and bottom. So there's quite a bit of information there that's available when you do the dynamic query. And again, we can double click so that we don't have to hover there the whole time and get a printout of that particular element in the output window. And if you don't want to see all of that information, you can just turn on what's important to you, make it a little easier to read. We mentioned the contour button here to change the display of our stresses. Right next to it is a button for layers. If we click that layers button, you don't really see any effect on the model, no additional dialogues. If we do a dynamic query, everything looks the same. If we do a dynamic query now, yeah, it's von Mises midplane. We do layers, right click. Oh, it is a different menu, but there are no layers available. What this is for is if we have composites defined, it allows us to see the various layers of the composites. So to take a look at that, if you want, go into the Maestro Models and Samples folder. That should open up this folder. And if you go into the composite, we can just open up one model here. I'll open this one at the top. And it's just a simple plate showing compression. If we look at the two load cases defined, we've got uniform compression and lateral pressure. I'm going to go ahead and run this model. And I have ran it once before, so I already have the results file generated. We'll simply overwrite that. It's a very quick model to run. If we want to see exactly how this model is constrained, we can look at the restraints. We've got 26 nodes restrained here. If we look at that graphically under View Restraints, you can see these two edges are constrained in Y and Z, and then about halfway down the plate, it's constrained in X as well. And these end nodes also have a rotational constraint. We can turn off the restraints and view the point loads. So under Loads, Point Load, you can see where the compression is applied. And if we look at the actual load case, we can look under the point force menu and see each one of those corresponds to 2,000 pounds of force along the edge with 1,000 at the end nodes. And if we come in, we'll go back to the element type view and then view, let's just do von Mises stress. Now this particular plate has 4 layers. If we come into our properties here, well, there's only one plate, GRP laminate, and it's got 4 layers, and we can see what the 4 layers are and the orientations of each layer. Let's do the dynamic query first, and we'll look for stress mid so we can see what stresses we have displayed here. Now they're all showing up as 0 for our von Mises stress. If we try mid X, still 0, but because it's a composite, if we come over here and turn on layers, and we right click, we can select just looking at the top layer. So in the top layer, now we can see what our stresses are for each thing. We can go back to von Mises if we want. While we're looking over this plot, if we right click, we can either change what's being plotted. We can go back to the local X, we can look at shear, come back to the von Mises, but we can switch layers as well. And we can see what's going on in the second layer, what's going on in the third layer, and what's going on in the fourth. And you can see the, well, bottom and fourth are the same in this case. But that's what the Layers tab will do for you. It allows you to look through all the various layers in your composites. So it doesn't really affect our model since we're just using steel single layer. Another thing I wanted to mention was with regards to listing of nodes and elements. Let's go to a smaller group. Let's look at one of the plate groups. We'll just view one of the cargo areas. And we are still looking at von Mises stress. If we list all of these elements in the grid view, when you right click in the grid view down here, there's a number of options. And if you selected certain pieces of this, you can use this to create a new group. As we tried before, we used the change fixed rows, so we'd be able to copy all of the titles of each one of these columns. You can use copy to copy the information to paste into another program, either spreadsheet or a Word document, and show all parts. To look into what show all parts does for you. The important thing that I wanted to mention here was that as you're exploring Maestro, you want to check what's available in these context menus because it changes depending on where you are. Now, even though we're looking at this same plate group, if instead of viewing the elements, if we view the nodes, you can see all of the information we'll get from all of these nodes, the forces and displacements. And if we right click here, we've got a slightly different set of options here. And one of the things in this one is you can create a general group associated with each one of these nodes. Well, it's not particularly helpful in this because we already have all of these plates in here, but that nodal group that we created earlier, those 4 specific nodes, if we wanted to recover information of all of the surrounding elements in there, if we list those nodes, we could select them and say generate a general group associated with these nodes. And what it does is it'll add any connected element or any element that uses that node will get added, and it automatically creates a new general group, which is under the extract folder under general here. But the main thing I just wanted to point out is that these context menus do change depending on where you are and what you're viewing. So it's worth investigating what's available in them.